Have you ever looked up at the night sky and wondered, what's beyond the stars? What secrets lie beyond the reach of even our most advanced telescopes? Well, today, we're embarking on a cosmic journey to the very edges of the observable universe. But we're going to do it differently this time. Have you ever watched a video from PBS Spacetime? If you love science, you've probably found that channel. Their videos are unique, but they're really technical. This video is for anyone who wants to know about the science, but are overwhelmed by all the details. The link to the original video is in the description below. Before we start, if you haven't already done it, please smash that subscribe button. Every new subscriber makes a difference to a small channel. Imagine the universe as a vast expanse, stretching 93 billion light-years across. This is the diameter of the observable universe, which includes galaxies, stars, and all the cosmic events that we can see from Earth. The universe has been expanding since its explosive birth in the Big Bang about 13.8 billion years ago. This expansion has shaped its current immense size. Now, it's important to understand that I intentionally used the word observable when I first described it. That's because we're only talking about the part of the sky that we can see with our telescopes and other instruments. Beyond that boundary lies uncharted territory, which may go on infinitely or be made up of space that is completely different from what we know. But remember, the observable universe is just a part of the entire cosmos. In other words, there's more out there beyond what we can see. The reason for this is that the light from these faraway areas have not yet reached Earth. Think of it like using a flashlight in a huge, dark room. In this room, you can only see where the light reaches, but just because you can't see everything doesn't mean nothing's there. But here's the thing, even if we wait forever, we may still not see these regions of space. Why? It's because space itself is expanding. The distance between galaxies is increasing, and the light from those stars are becoming increasingly faint. Imagine you're surrounded by a sea of galaxies, each one a glimmering point of light. As space expands, these galaxies move further away from you, and their light grows dimmer. Eventually, they cross a threshold where they become too faint to see, no matter how long you wait. This boundary is called the cosmic horizon, and it's the line where we can't see past because we're limited by the speed of light. But wait, I'm sure you're now asking, what does the speed of light have to do with the cosmic horizon? Well, even though light speed is the fastest thing in the universe, zipping through space at a mind-blowing 671 million miles per hour, it still has limits. The universe is so grand, so unimaginably large, that the speed of light is more like a tortoise, where instead we need a Ferrari to realistically travel across the galaxies. So because of this limit, when we look at distant objects, we're not seeing them as they are now, but as when their light first started shining toward us, millions or even billions of years ago. In a sense, gazing deep into space is like looking back through time. The further away a galaxy is, the longer its light has been traveling to reach us, and the older those stars are. Beyond those farthest galaxies is the region of space that remain invisible because their light hasn't had enough time to reach us since the beginning of time. It's just too far away, and as the universe continues to expand, those galaxies in that hidden area will be carried away with it. Their light will never reach us no matter how long we wait, and those distant worlds will forever remain beyond our cosmic horizon. This may raise new questions. What's past this line? What's at the cosmic event horizon? The cosmic event horizon is like the horizon on Earth. As you look out, you really can't see what's past that distant line. But instead of the sky appearing to meet the land or sea, the cosmic horizon is the point where the universe is moving away so fast that light, which is traveling at its finite speed, will never reach us. In other words, the galaxies beyond this point are receding faster than the speed of light, because the universe is expanding at a faster rate than light travels. So what's past this line? Are there alien civilizations that evolved eons ago that we'll never know existed? Maybe the universe was filled with ancient civilizations that rose before Earth was formed. Maybe they traveled across space and colonized entire galaxies. But as the universe expands, these regions of space will slip away into this unreachable void. Everything outside this bubble moving away faster than light can travel, slips away forever by the laws of physics. Even if we could travel at the speed of light, the ultimate speed limit in the universe according to Einstein's theories, we still wouldn't be able to reach the edge. Some scientists have proposed hypothetical concepts like warp drives or other technologies that could allow us to bypass this limitation. These warp drives would work by bending space-time around a spacecraft, creating a bubble that moves space itself instead of the ship moving through space. Essentially, the warp drive would compress space in front of the ship while expanding space behind it. This will allow it to travel faster than light without actually moving at that speed. In any case, the idea of reaching the edge is a bit misleading, because if the universe is infinite, is there really an end? On the other hand, some theories suggest that the universe could be curved, like the surface of a sphere. In a curved universe, if you traveled far enough in one direction, you would eventually come back to your starting point, just as you would if you kept walking around the Earth. In the meantime, our exploration will have to continue with telescopes and observatories. We can't travel to the distances of the galaxies yet, but we can still peer deeper into space and further back in time with each new generation of telescope. Thanks for joining. Keep exploring, keep learning, and never stop asking the big questions. Until the next time.